Using trigonometric identities to solve problems. Now in Core 2 we've come across two new trigonometric identities, which are sine squared theta plus cos squared theta is always identical to 1, and that tan theta is always identical to sine theta divided by cos theta. Now these can be very useful when looking at simplifying or showing that two equations are equal. Now we can also use these trigonometric identities to solve problems. Now the first problem here isn't actually going to use any of the trigonometric identities to solve, which is cos x is equal to root 3 divided by 2, and we want to find all the solutions in a range from 0 to 360. Now remember that this means that cos of x is equal to root 3 over 2, and we're asked to find the angle. So to do that we need to use our inverse function to find out what cos to the minus 1 is of root 3 over 2, which if you check on your calculator you should know that x is equal to 30 degrees. But we're asked to find all the solutions in the range 0 to 360. Now the easiest way to find all the solutions is to quickly sketch the trig function you're looking at on a graph. So we're looking at cos here. So cos goes between 1 and minus 1. And here's our 90, 180, 270 and 360 degrees. So cos of 0 is 1. So it starts here. It cuts through cos of 90 is 0. Cos of 180 is minus 1. So it goes like this, which you should all be fully aware of. Now, if it is 30 degrees in from the side, I mean my graph isn't to scale, it must also be 360 degrees in, 30 degrees in from 360. So 360 take away 30 degrees is 330. So my two solutions are 30 and 330 degrees. Now the second question we're asked to solve is we're asked to solve sine theta is equal to root 5 cos theta in the interval 0 pi to 2 pi. So this time we're working in radians, so make sure that you set up your calculator in radians before tackling this question. Now we can't solve this in its current form because we have two trigonometric ratios within the question. We have sine theta and cos theta. We should know, however, that sine theta divided by cos theta is equal to tan theta. And we're going to use that here. Tan theta is equal to sine theta divided by cos theta. And we're going to use that point in this question. So if we divide both sides by cos theta, we're going to have sine theta divided by cos theta is equal to root 5. And we know that this sine theta divided by cos theta can be written as tan theta is equal to root 5. And if you pick up your calculator and find out what tan to the minus 1 is of root 5, you get theta as 1.150 to 3 decimal places. Remember, you should have your calculator set for radians. If you don't get that, it probably means you're in the wrong form of measuring angles. And we're asked to find all the values in the range from 0 to 2 pi. Now yet again, the easiest way to do this is to sketch yourself the tan curve between 0 and 2 pi. Now it starts off at 0 and flies up. It doesn't get to pi over 2 because you can't do tan of pi over 2. And it flips here, going through tan of pi is 0, and again here. Now this 1.150 is less than pi over 2, so it is 1.150 in from there. So that means it also needs to be the other place where it's 0, which is here. It needs to be 1.15 in from pi. So you do pi, add on 1.15 to define the solution, which if you do that, you find that the second solution is 4.292. And these are our two solutions for theta in the range of 0 to 2 pi. So a quick sketch of the curves will help you find all the solutions for a given trigonometric problem.